This video is going to cover the basics of linear relationships. So linear relationships start in year 7 and go all the way through until year 12, getting progressively more difficult as you go along. You learn a lot of the basics in year 7 and 8, looking at patterning and writing rules to do with the next shape in the pattern. And then when you get to year 9 and 10, you start to learn how to find the gradient and the rule from graphs, from tables, and also from 2 points. So that's what we're going to cover today. We're doing linear relationships, finding the rule from a table, from a graph, from 2 points, and then I've also put in a worded problem at the end. So to start with, you just need to be reminded that linear relationships refer to straight line rules where they increase or decrease at a constant rate. So basically what that means is the slope is the same. And another word for the slope is the gradient. And when we talk about gradient in maths, we use the letter M to write down what the gradient is. So you'll see that when we do linear relationships, they have a general formula of y equals mx plus c. So we're looking at how we find y if we know the x value and the gradient. So firstly, we've got on the screen here a green line sloping upwards, left to right. And that shows a positive gradient. And I've put there that the general formula of that would be y equals mx plus c, because the gradient, which is m, is positive. And it could be steep or it could be quite flat, but it is still a positive number. The steeper the line, the bigger the value for the gradient. So for example, a line with a gradient of 10, so that's increasing by 10 each time. So that shows us quite a steep gradient, whereas something like going up by 2 is a lot flatter if we were to compare them. We then have a red line, and the red line shows a negative gradient, which slopes downhill, left to right. And the only difference here is that I've written the general formula as y equals negative mx plus c. And that's because the gradient is now negative. The yellow line shows a horizontal line, which denotes a gradient of 0. And that's because it's a flat line. And if you think about it, that means there's no slope, or the slope is 0. So you'll notice there that the m has disappeared from the equation. We've just left with y equals c. And that's because you should know now that if the gradient is 0, if we do 0 multiplied by x, the x will disappear because it is just 0. And then the last line is a special line, and that is a vertical line. And you'll notice there that I've written that the gradient is undefined. And the reason that the gradient is undefined is because what we call the run is 0. And as we get into doing the rule from a graph, we use the gradient formula, which is rise over run. And if the run is 0, we can't divide by 0. It gives us an undefined answer. So we actually have a completely different rule for this one, and it becomes x equals something. And that something, that number, is wherever that vertical line goes through on the x-axis. So we'll move on to our first example now, which is finding the rule from a table. So I've just written the general formula again, which is y equals mx plus c. Now the y and the x, they obviously come from the graph, the x and y axes. The m is the gradient and the c is the y-intercept. So I am just going to write those down. M is gradient and c is your y-intercept. Now your y-intercept is actually where the line crosses that vertical axis, and that happens when x is 0. So the coordinate of the y-intercept is always going to be 0, c. Now c could be a positive or negative value depending on where it goes through that y-axis. So our first example here, we've got a table. We've got the x values, which are -2, -1, 0, and 1. And then underneath those x values are the y values. So we have 3, 5, 7, and 9. And what we need to do is to write our rule, we need the gradient and the y-intercept. So straight away, I know that the y-intercept happens when x is 0. So I'm actually going to put a box around that 0, 7, and I'm going to write down here, leaving a space for the gradient, I'm going to write y-intercept equals 0, 7, and I'm going to write it as a coordinate. Then I need to do the gradient. So the gradient is what it's increasing by. Now, the important thing to look at here is to make sure that the x values go up by 1. Because if the x values don't go up by 1, then you need to divide by what they go up by. Because you're looking at how is it increasing each step, not each 5 steps or each 2 steps, etc. So this one is going up by 1. So we can see here that our y values are going up by 2 each time. So I'm just writing plus 2 underneath that. So that means our gradient is positive 2. And the fact that it's add 2 means that it's a positive line. And if we were to put these points on a graph, you would see that it would be going uphill from left to right. So we would have our gradient as 2. So then lastly, we write in our formula, our rule. So I'm just going to write here, our rule is y equals 2x, which is 2 times the x value, and then we add on 7. Now, to check that rule works, we just put it into one of the values in the table. So let's do 2 times 1. So 2 times 1 is 2. If we add 7, we get 9, and that's the number that's under the 1 in the table. So we know that we've got it right. Moving on to example 2. So this time our x values are 2, 3, 4, and 5, and our y values are 5, 2, -1, and -4. So again, I'm going to write down our gradient. That's the first thing that we need to find. And our gradient, we can check the x values go up by 1, so we can just go by what is happening between each of the y values. And this time you'll notice it actually goes down. So what we're going to do is we're going to write -3, -3, -3, so that when we write our gradient m equals -3. Now, this time the y-intercept isn't as easy to find because the 0 is not in the table. We could extend the table back and, continue the pattern, or we can do the gradient multiplied by one of the values in the table and then work out how much we've got to add or take. So if we do that, let's do -3 times 2. So I'll just draw an arrow over here. So we're doing -3, which is the gradient, times the x value, because remember, y equals mx plus c. We're trying to work out what we add on. Now, the y value we need is 5. So -3 times 2 is -6. To get back to 5, we have to add 11. But before we do that, let's just check that works with another one. So if we check with the 5 now, -3 times 5 is -15. If we add 11, do we get to -4? Yes. So we know that the y-intercept must be 0, 11. So that means our final rule is going to be y equals -3x. So that's y equals -3 times x plus 11. And that's how we get our rule from a table. We find our gradient using the difference pattern, and then we find our y-intercept either by looking for the 0 in the table, the x value of 0 in the table, or we can actually do the multiplication and find out what we need to add or take to get to our y value. Our next lot of examples are looking at finding the rule from a graph. So this time we've actually been given what the graph looks like. So one thing you need to know for doing this is that the gradient now is what we call rise over run, which is what we were just doing, but it's a bit more visual this time. So when we do rise over run looking at a graph, we need to make sure we pick 2 points on the graph. And when we pick those 2 points, they need to be exact coordinates. So what I mean by exact coordinates, we can see on this graph that there is an exact coordinate at 4, 4. So I'm going to put a dot on 4, 4. And then I'm also going to put a dot on 3, 2, because you can see that there is also an exact point. And then what we do is we find our rise over run. To do that, we draw in a triangle. Now, I always draw above the line if it's a positive line and below the line if it's a negative line. That's not a rule. You don't have to do that. The reason I do that is because it reminds me that it's a positive or negative line. So the first thing is I draw in my triangle, just like so, and I write over next to the triangle rise. So our rise, how many squares up did we go? 2. And then our run is the horizontal distance, and we went across 1 to get to our next point. So to do our gradient now, our gradient is rise over run, which is 2 divided by 1, which of course is just 2. Then we need to look for the y-intercept. Now, the y-intercept happens where it crosses the y-axis. And you can see here in this example that there's already a red dot on that. And if you have a look at where that line is going through the y-axis, it is at 0, -4. So the rule for this line would then become y equals 2x take away 4, because remember the gradient is what goes in front of the x, and then the y-intercept is what is added or subtracted. Now this time it was a subtraction because the y-intercept is negative. So again, we just look to see if our slope is positive or negative. In this case, it was going uphill left to right, so I drew my triangle in above the line. Again, not necessary to draw your triangle in above the line, just a reminder and a bit of a helping tool. Second example, we have a downward sloping line. So this time when I pick my 2 points, so I can see that there is a point there at -3, 2. So I'm going to put a dot on there. And then I'm actually going to also use the red dot that they've put on there already. So I'm just going to colour that in yellow. So you can see there that I've picked those 2 points. Now, because this is a negative line, I'm actually going to draw in the triangle below the line to remind myself that it is downhill. So to do that, I just draw my triangle in like so. And again, we write our rise. So how far down did we go this time? We went down 1. So I'm going to put -1. And that's just to remind myself that I have to put a negative when I write my gradient. And then we have our run. We went across 3. So when we do our gradient this time, we've got m equals rise over run, so -1 over 3. And we don't simplify that because we can't. We don't make it a decimal. We just leave it as -1 over 3. If it was a fraction that could be simplified, for example, -2 over 6, we would simplify it down to -1 over 3. And then we look for our y-intercept. Our y-intercept is 0, 1. So our rule then, we would do -1 over 3x, because that's our gradient before our x. And this time the y-intercept was positive, so it will be +1 on the end. The next example is looking at the rule from 2 points. Now, we were doing rise over run when we've got the visual graph and we can actually see what the graph looks like. We can use rise over run. We are doing the same thing when we're given 2 points, but we just use this formula here, which is m equals y2 take away y1 divided by x2 take away x1. And the good thing about using this rule is that it gives us a positive or negative answer immediately. So we don't need to draw the graph to know whether it's positive or negative. It will actually give us a negative answer or a positive answer depending on whether the line is an uphill or downhill line. So the first thing we do when we're given this is we need to label our coordinates. So I've got here example 1, find the rule of the line that joins 5, 18 and -3, -14. So all I'm going to do is I'm going to label the first coordinate, coordinate 1, and the second coordinate, coordinate 2. And all I've done is just write it above it. Then I'm going to label the x coordinate in the first coordinate as x1 and then the y coordinate as y1 and x2 and y2 in the second coordinate. You don't have to do this every time, but just while you're getting comfortable with it, you need to. That way you don't make any mistakes. Then we do m equals y2, which is negative 14, take away y1, which is 18, divided by x2, which is negative 3, take away x1, which is 5. So we end up with negative 32 divided by negative 8, and that answer gives us 4. So that means in our rule so far, we know y equals 4x plus some unknown number. Now to find that unknown number, that constant, what we need to do is we can sub in one of the coordinates. Now ultimately it doesn't matter which coordinate you sub in. For me, I choose the one that is the smallest numbers or the least amount of negatives, so that means it's the least amount of chance of making a mistake. So I'm going to sub in 518. So that means where I see y, I'm going to put 18, and where I see x, I'm going to put 5. So I'm going to have 18 equals 4 times 5 plus c. So we've got 18 equals 4 times 5, which is 20, plus c. And then if I move the 20 to the other side, it becomes a takeaway. So I end up with c as negative 2. Therefore, the final rule would be 4x, y equals 4x, take 2 for this first example. Example 2, same thing. We've got find the rule of the line that connects negative 2, 10 and 7, negative 17. So again, I'm just going to label those 1 and 2, and then x1, y1, x2, y2. It doesn't actually matter which coordinate is 1 and which coordinate is 2. Then I'm going to use the formula of gradient. So I'm going to do negative 17 take 10 divided by 7 take away negative 2, which gives me negative 27 divided by 9, which is negative 3. So far, I know that I've got y equals negative 3x plus c. And you can see here that it came out as a negative answer. So if I was to plot these 2 points, there would be a downhill sloping line from left to right on my page. Now, to find c, I need to sub in a point. I'm going to sub in negative 2, 10. Ultimately, it doesn't matter. So we end up with 10 equals negative 3 times negative 2 plus c, which is 10 equals 6 plus c. So hopefully we recognise that c should be 4. And then we can write our final rule would be y equals negative 3x plus 4. And the last example for this video on linear relationships is a worded problem. So it's just being able to write a rule from a worded problem and then use that rule to answer a question. So we've got a plumber charges a $40 call-out fee and then $50 per hour for a job. Write a rule and then use this to calculate the cost of a 5.5 hour job. So step number 1 is I'm going to underline the important part. So we've got a $40 call-out fee and $50 an hour. And then the last part is looking at the 5.5 hour job, the cost of a 5.5 hour job. So the first thing is looking at the rules. So I'm going to use C for the cost. So I'm just going to write here C equals cost, and I'm going to use H as the hours. And the reason I'm defining the variables is to show you that we don't always have Y and X. We could have C for cost, H as hours. We could have T for time. We could have V for volume, velocity, anything depending on the context. So the first thing is we notice that they charge $50 per hour and a $40 call-out fee. Now that $40 call-out fee is a once-off fee that they charge regardless of how much work they do. So when we write our cost function, we're going to have C equals and it's going to be 50 times the hours because that's how much they're going to charge for every hour they work. So it's 50H. And then we're going to add on that call out fee because that is only added on once. So we've got 50H plus 40 as our rule. So we've got C equals 50H plus 40. And I'm just going to write up there where I define C equals cost. I'm going to put it in dollars. Then to figure out the cost of a 5.5 hour job, we're going to do sub in H equals 5.5. And we'll end up with C equals 50 times 5.5 plus 40, which works out to be $315. So we would say the cost, because it's a worded problem, would be $315 for 5 hours. 5.5 hours, sorry. And again, we only need to do that sentence answer because it was a worded problem. So hopefully that gives you a little bit of an idea of how to do linear relationships. Remember, you can always go back and rewatch the sections that you need to rewatch and really consolidate those to get a good understanding.